In a recent video, Ivan connected the output of the pressure sensor uh, to a light bulb and then battery voltage, and viewers had a question whether this is safe or not. And Ivan mentioned that for the control module it's okay because it's a high impedance sensing circuit, and I totally agree with that. But what about the pressure sensor output? What happens when we connect 12 volts through a light bulb to it? To answer that question, here we have a Honeywell PX3 series pressure transducer, and we are going to replicate the conditions of Ivan's test. Here we have a 12 volt power supply. It's limited to half an amp just as a precaution, and it goes to a voltage regulator 5 volts and then goes to the sensor, and the return of the sensor is connected to a voltmeter here. It's showing 0.5 volts as expected, because this is what it's supposed to show at the atmospheric pressure. But what we are going to do now, we are going to take a light bulb. This is a map light that is rated for 12 volts and 10 watts. And we are going to connect it right to the output of the pressure transducer. And we'll see what happens. So here it goes. Goodbye, cruel world. So what happens, we get 400 milliamps, as you can see on the power supply, and the voltage at the output of the sensor shoots up to 8.8 volts. So what does it mean? Well, it means that there is 400 milliamps going through the light bulb to either pressure transducer, ground, or to the voltage regulator, and then goes to the ground. Let's check what exactly happens. So first we will check the voltage output of the regulator. Is it still 5 volts? So let me just get the lead and connect it to the voltage regulator output. So here we are seeing 5 volts, but what is it going to be when we connect the light bulb? So we see that the voltage went up to 5.3 volts, so the voltage regulator lost technically its voltage regulation, though not by much. So it looks like there is some current going backwards to the voltage regulator. What we're going to do now, we are going to switch the multimeter into 10 amp mode and check the amperage that goes through each of the lines over here. So firstly, we are going to get into the ground wire for the sensor. Okay, we are ready for the experiment. It's 380 milliamps going through the ground of the pressure sensor 380 out of 390. So we are supposed to find another 10 going to the voltage regulator, backfeeding it. Okay, so let's do this experiment. We connect the ground back. Instead we are unlocking the voltage regulator output lead, and then get our amp meter into that circuit. Okay, so now we can repeat the experiment. Okay, yeah, we do have a 10 milliamp back feed on that line. Oh well, that's what we have. So let's recap. When we connect the light bulb, we get 400 milliamps going through the light bulb, and then it splits. Most of it, 390 milliamps, gets dumped by the amplifier in the pressure sensor, because it's trying to maintain half a volt, so it tries to dump as much to the ground as possible. But it cannot do it all. I guess it saturates or something, and the rest of the voltage finds its way through what I presume a clamping diode inside it to the power supply line, and then it backfeeds the voltage regulator. As a result, the voltage regulator loses its voltage regulation, though not by much, because 5.3 and 5 volts is not that bad. But good news that there is no magic smoke, no device is damaged. So I would assume that if your pressure sensor and the voltage regulator are as beefy as these ones, no damage would occur.